Yeah, it does hear a lot of random conversation. Are you recording? I just started. It didn't get your next joke, so. Okay, guys. We are doing critical numbers, so we're still looking at derivatives, but we're going to look at what the derivative can tell us, other than just the slope of the tangent line. So I give you this f of x here. It's x cubed minus 6x squared plus 15. You guys with me? All right, we have to find f prime of x. So what is f prime of x going to equal? Okay. Hopefully you guys are good at that at this point. Yes? We're doing okay with it? All right. Part B I'm going to do over here just so I have enough room. It says for what values is f prime of x equal to 0? That just means take your derivative, so 3x squared minus 12x, and set it equal to 0. Okay, so I'm going to factor out a 3x, x minus 4. So I get 0, and I get 4. Okay, with me so far? Nothing too complicated, right? Okay, part C, use your calculator to graph the function. What I mean by that is to actually graph f of x. You are graphing.
That's the spot on the line. On the left.
Where you at?
Do we have the derivative or the original? Oh, the original. Yeah. Graph f of x.
I'm still at the thing where it says calculator.
So change your phone.
It's chocolate.
I'm going to spell your question, and then you're going to use that.
Wait, is that when you're talking about maximum?
Don't like a really long equation.
Wait till next minute when we figure out what the second derivative shows us.
The second derivative.
Yeah, I'm saying they should make voices.
All right, guys, so you graphed it, right? It's a nice cubic function. Then part D here, I ask you what are the relative max and mins of f of x? So of the function you just looked at. So I'll do part D down here. What do you think? Can you calculate on your calculator a max or a min? You might have to change your window so you can see them.
Is it y equals x?
It's like the maximum is this value at x equals this value. Everybody understand why we don't have an absolute max or min? Remember? It goes to infinity, so we can't have absolutes. You can read it off your paper, but it's too small up here.
I'm just wondering, why are you graphing the derivative?
Well, graph the derivative.
You're graphing the derivative. How do you graph it?
One of you would have a parabola, and one of you would have a zero.
That would make sense.
Wait, what happened? Is she okay?
I thought she was gonna live destroyed.
For what?
Is she at school?
Why are you like laughing?
No, I was like, dang, I wanted to see it.
All right, guys. So what you get for a max? Okay, what is the? That's where it occurs. Yes. Yes. So 15 at x equals 0. And what about your minimum?
Negative 16 at x equals 4.
Okay, good. All right, are we okay with the max and the min? That's just from your calculator. That's all the stuff we've done before. Okay. Part E says observations. Do you notice anything? notice that those are the same as those, right?
So the derivative tells you
That's fair.
I don't know.
It is. So, what we notice is that the relative max or min will happen
When the derivative is zero.
where f prime of x equals 0. Also, where f prime of x is undefined. So we didn't have that in this case, but if you happen to have your derivative is undefined at a certain point, that would indicate a max or a min on your original as well.
Where does
Okay.
the prime
Like if you took the derivative and you ended up with something over x minus 2, like, okay, then it's undefined at x equals 2. That sort of thing. So we aren't into too complicated of derivatives just yet. How, what?
He's so
I'm laughing at something. You're so mean to me.
guys are being recorded.
All right, guys, so if you turn the page, those are actually called our critical numbers. So where the derivative is 0 or undefined, that's where we have a critical number.
Oh no, number lines.
There are number lines. And guys, you can put your calculators away. We are done with them now. That was just for you to explore it and figure it out. You will not actually have the calculator at any point on this test. So. Okay, so let's do g of x together here. Here's the next one. All right, g of x is x cubed minus 12x. I'm asking you to find the critical numbers for the function, and without graphing, tell me where the function is increasing, decreasing, and has extrema. Those are the maxes and the mins, okay?
So the critical numbers are just the places where, okay.
Yep, so we're gonna find the derivative first, okay, and then set it equal to 0. All right, hold on, you're ahead of me. All right, so I'm gonna find g prime of x. Just power rule here, guys. What's my derivative?
3x squared minus 12.
3x squared minus 12. Okay, good. So I'm gonna set that equal to 0. I don't care how you solve this with your factoring the critical numbers.
Oh. Where prime
You got it. Guys, does that 3 in front matter?
No.
No, I could just divide both sides by 3, right? This is not how you had to solve it, but this will help us with what we have to do next. So my critical numbers are x equals plus or minus 2. Okay, so that's one part. We're okay with that?
Yes.
Yes. All right. Now, what I... Man, this is so weird today. It's all glitchy. All that. Okay. It's not like me today. Okay. No, we're not done with this one. Have you told me where it's increasing, decreasing, or max or min? No. Okay.
How do you figure out from which side the graph is coming?
What do you mean? Like as far as increasing and decreasing?
Yeah, so like, I know it's like either it's good or negative, but I don't know.
Yeah, that's what we're gonna do next. Let's figure that out. Okay, guys, we've done number lines many times before, right? We're gonna do another one. My critical numbers are gonna go on my number line. Okay. What do we want to test that is easy? 0, okay? Where I'm plugging it in is to this factored form here. So if I put a 0 in here times a 0 in here, what do I get? Positive or negative answer?
Negative.
Negative. Will this alternate? Yes. Why? Not a bounce. Okay. It doesn't have multiplicity, right? It's not x minus 2 quantity squared. Okay. It's just x plus 2, x minus 2. So yes, it will alternate. Okay. So what this means, when there's a positive, and now this is all from your derivative, when there's a positive, your original graph, the original, what were we, g of x on this one, I think, is increasing. So it increases until we get to an x value of -2. And then what happens? Yeah, so I always draw just like a little picture, increasing, decreasing, increasing. Now, is this like a perfect graph of our original equation? No. I don't know where the x-intercepts are, I don't know where the y-intercept is, nothing like that. All I know is what is happening at -2 and 2. It is changing from increasing to decreasing and from decreasing to increasing.
I'm gonna make her.
Okay, so if I asked you where it's increasing and decreasing, that should be pretty easy to write out. What would you tell me for increasing? Good, and perfect. And where's it decreasing? Yep, -2 to 2. Okay, so that's another part of what I asked you. Then I asked you about relative max and min. So if it's increasing to -2, what is happening at -2?
It's a max.
A maximum. How could we figure out what the maximum actually is? Okay, plug in -2 where?
The original.
The original. Because it's the max or min of the original one that I'm talking about. So if I plug a -2 into that original, what do I get?
-8 minus 6, so plus 24, 16.
16 at x equals -2. And then, do you guys see how 2 is where the relative minimum is going to occur?
-16.
How do you know it was 16?
So, we know the x value where it's happening, right? Okay. Try to scroll up here. So when x is -2, I know I have a maximum, so plug -2 in here. You see what you get. Yep. And then +2 gave us -16, is that right?
Yeah, I did this.
Okay. So -16 at x equals 2.
Oh, okay.
Okay? You just have to remember think about what you're actually finding. You're not finding the max and min of the derivative. You're finding the max and min of the original, so plug them into that, okay? All right, you guys try the second one. And guys, the way this is written, I would rewrite it. Isn't this the same as 1/4 x to the 4th?
True.
Okay, I don't need anyone doing the quotient rule with a 4 in the denominator. Okay. Just saying. Guys, I just want to make sure you've got the right derivative to begin with. Because if that's wrong, the rest of it is troublesome. Yeah, it's not too tricky.
You're putting 0 to the top. 0 to the top. 0, 0, 0. Wait, if you're 2, I don't know.
They're both relative mins. You can have multiple relative
Okay,
minimums,
so
right?
it doesn't matter.
Nope, you should tell me like, it's this at this and this at this. That's okay.
Max is 0. Wait, relative max is 0. The relative mins are also at 0. If they're right, it's really nice. Yeah, 2 to the top, 4, 6, 4, 0, x equals 0. Negative 4. 0, negative 4 at x equals 2. Wait, you plug it into the original? Yeah.
Because you're finding the max or the min of the original, right? Like, remind yourself of that. Well, are they going to be different?
16 more. It is 4 at x and negative. Or x equals 2 and negative. If it's 8 and negative 2.
For the relative min, can you do like plus or minus 2?
Negative 2.
Because it's the same. Yeah. If it was different y values, that's different. But
Oh, see.
I think I got it.
all right, so did we have increasing from -2 to 0 and 2 to infinity? Decreasing from -infinity to -2 and 0 to 2. You good on that part? Okay. Let's see, relative max, 0 at x equals 0.
Yep.
Okay, and relative min of what? -4?
At x equals 2 and a negative.
Yeah, at both plus or minus 2. Okay. We doing all right? We just have one more example after lunch, okay? Because bell's gonna ring here in just a second, so we'll pause here.
Oh, it's a lot left.
All right, so try this last one.
What's the chain rule? We'll learn about it later.
Then 6. Yeah, you don't have a chain rule. It's good times.
We're doing 10, 6, 2. No.
Did you just say this is annoying?
Yeah, wait.
Why?
Do you? Other? Wait. Yeah. There's more than that. There's 2, 3. Oh, there's 2 double solutions.
No, figure it out.
Wait. Simplify x to the power 4 minus. Just do 5.
You gotta take. Did you take your derivative?
Why am I just... I just started simplifying it right away.
Just right away, like I'm
Yeah.
setting this equal to 0. No, derivative
Oh.
first, guys. Right?
Yeah.
Did you guys like lose everything you learned over lunch?
Oh, yeah.
That happens a lot.
So there's 2 imaginaries.
Here's your derivative. That is what you're setting equal to 0.
Right.
Right, okay, with me? You do not have 4 critical numbers here, guys.
Just 2.
Okay, yeah. I was kind of worried.
Right, we can't, the imaginaries do nothing for us, so.
Or do you just give me that?
So 0.
You doing fun? Oh, your brother?
You try to
What, like,
go
signing up
back
for
into
it?
alphabets, right?
If you're looking for the max and the min, or looking
So like when you're doing the number line, you plug it back into F prime.
yeah, because you're testing the derivative. Wherever the derivative,
Oh,
positive or negative, tells you about if the original is increasing or
Plus or
decreasing.
minus 1 higher than negative.
Yeah, that's mid.
Plus or minus 1 higher.
You don't use the
Plus or minus 1
guys.
but I'm just saying, there is no.
We don't need it.
So we don't need it.
Correct.
I just don't want
So,
Yes.
is x squared minus, x squared plus 1, is that imaginary?
What do you mean is that imaginary?
Like, the things that are made, are they imaginary?
Like the solution?
Yeah.
Yeah, they would be imaginary.
I was right. This is 0 minus 0.
I've had this great.
It's so funny. I'd honestly do that.
You would.
Damn.
God.
We're genius.
That's some old Concord.
I'm gonna go.
What?
Things fall apart. Yeah.
All right, guys, what'd you get for a relative min? Are you there?
Yes.
Things fall apart. Doesn't it answer your issues?
I like the t-shirts. It's a good pattern.
Whatever. One is 0. So
Nobody else.
What is the max going to be, guys?
What's -4?
Not 0.
then I messed up.
So when you plug -1 in, you get -1 plus 5.
4. Right.
You plug it into the original.
Why?
Because I'm talking about the max or the min of the original function. That's what this is telling you. All this increasing, decreasing, max and min, it is all of this guy.
Then what do we plug back into the 0 equals that thing?
This.
Yeah?
When you're testing your number line, you are testing the derivative.
Okay.
But I'm asking you for the max and min. I'm not asking you for the max and min of this. Right? Like, this is no chance that that's what that graph looks like, right?
How often is it found? He's like, when you get to 10 years.
This is the stuff that, like, you gotta really understand in this unit. So that in Unit 11, when I add a whole bunch more graphical stuff to it, you're like, okay, I'm okay, because I was really solid on it.
Like at school.
Okay.
Like 50 bars.
No pressure. Just telling you.
Dude.
Alright, guys, did you get 4 at x equals -1 for the max?
Job.
Okay, and that's all I asked you for, was the relative maxes and mins.
I might have one.
Alright, do we feel okay? Yes? Yes? Solomon, are we adding and subtracting? If I plug a -1 in here, here.
Oh, that's not
Friday, dude.
That's not the rules tomorrow.
You're not
Really
alone.
the worst.
Why?
It's the max or the min of the actual function, guys. Not the max or the min of the derivative. Okay? Plug it into the original. Alright. Your homework is kind of weird. So again, look at what this is. It's like a whole bunch of pages. I have you skip a couple, like, and the circuit training worksheet you started on, I'm just going to make sure you have that done next time too. So take a picture, write it down. I would write it down because you guys take pictures and then forget to look at the picture you took. So you're not the only one.